Another interesting thing to look at is the voltage standing wave ratio. So we can add a new graph from here. Just right click, new graph. Let's choose a rectangular one this time. And you right click on the graph, go to add new measurement. You can go to linear measurement and then VSWR. Choose transmission line 1 as your source. The port is port 1. And then click on apply. Now let's simulate. And we see that our VSWR is 2. This value tells you what the ratio between the maximum and the minimum of the standing wave that's created on the transmission line by the mismatch is. Now, if we look at our previous graph and we change the marker readout to tell us the reflection coefficient, we can see that the magnitude of the reflection coefficient is about 1/3. Now, the VSWR has got a very simple relationship with the reflection coefficient, and that is VSWR equals 1 plus modulus of gamma divided by 1 minus modulus of gamma. So you can calculate this easily by yourself, and you'll find out that if you have 1/3 as the magnitude of the reflection coefficient, the VSWR will have a value of 2. Now, what happens as I change the length of the line? When I change the length of the line, nothing actually happens to the VSWR. Why is that? The reason for that is that you choose a specific termination for your transmission line. This termination establishes a standing wave along the line. Now, it doesn't matter how long the line is. The standing wave is determined by the mismatch at the end of the line, not by the length of the line. All you're looking at is the ratio between the maximum value of the standing wave and the minimum value of the standing wave. And these maxima and minima will repeat themselves along the line, but changing the length of the line doesn't actually make any difference. What makes a difference is changing your termination. That's what determines your VSWR. Now, to prove that, let's go back to our schematic by double-clicking on its name. Click on the tune tool, the screwdriver, and then go down to the resistor value, the terminating resistor. You can see it changes into a blue color, and it appears on the tuner as well now. You can press the escape key to get back to the normal cursor. Then double-click on graph 2, which is where you've got your reflection coefficient. And you can see now that as you change the terminating impedance, the VSWR will change. If I go down to 50 ohms, you can see the VSWR is 1. What does that mean? That means that the maximum voltage along my transmission line and the minimum voltage along my transmission line, in terms of the standing wave that's created, are the same. So the maximum voltage of the standing wave and the minimum voltage of the standing wave are exactly the same, and their ratio is 1, and the amplitude of the standing wave is hence 0, so there's no reflected voltage at all. As you go up to 100, you can see you get to 2, and as you increase the mismatch further, you can see that the VSWR becomes bigger and bigger, meaning that the amplitude of your standing wave is bigger and bigger, and you're getting more and more reflections. Now, let's observe another interesting thing. At the moment I'm at 200 ohms, and I start going down towards 50 ohms, which is my matched impedance. You can see the VSWR decreases, carries on decreasing, until it gets to 50 ohms, where it has its minimum value of 1. Now, as I carry on decreasing the impedance further, I once again mismatch the line, and hence my VSWR goes up again. In fact, you can see that for 25 ohms, for instance, the value of VSWR is actually 2, the same as you get with 100 ohms. And this is to do with the fact that the VSWR is related to the magnitude of the reflection coefficient alone, but it has no information on the angle. Now, the magnitude of the reflection coefficient is the same for 25 ohms and for 100 ohms, but the angle is different. So the VSWR just gives you an indication of how much mismatch there is in the line, but in as much as it's related to the reflection coefficient, will give you no information on the angle. This completes the first set of basic tutorials on transmission lines, and there will be more to follow on various other topics, including S parameters and other design parameters utilized for design of amplifiers and transistor circuits.